Biotin plays an essential role in the conversion of nutrients into energy, and this has a direct impact on intestinal function. When the body uses carbohydrates, proteins, and fats efficiently, digestion becomes smoother and less overloaded, which contributes to balanced intestinal transit. In the intestine, biotin helps modulate enzymatic activity. Certain enzymes depend on the presence of this vitamin to act on the breakdown of fatty acids, amino acids, and glucose. This process ensures that nutrients reach simpler forms so they can be absorbed by the cells of the intestinal wall. Another important point is the action of biotin on the beneficial bacteria present in the intestine. The vitamin promotes a healthy environment for the intestinal microbiota, which in turn improves nutrient absorption and helps prevent discomforts such as excessive gas and abdominal bloating. Biotin also contributes to maintaining the integrity of the intestinal mucosa. When the mucosa is strengthened, it acts as an efficient barrier against unwanted substances that could cause irritation or digestive imbalances. The energetic balance provided by biotin is reflected in intestinal motility. An intestine with adequate energy levels can perform peristaltic movements in a coordinated way, ensuring the regular elimination of waste. The fermentation of fibers and the production of short-chain fatty acids by the microbiota also benefit from biotin. These fatty acids serve as fuel for the cells of the colon, reinforcing the vitality of intestinal tissue. Biotin also acts on the synthesis of fatty acids that make up cell membranes. This is important because intestinal cells need to remain intact to perform their absorption function. A deficiency in this structure could compromise the passage of nutrients. Adequate levels of biotin help reduce fatigue associated with the digestive process. When nutrients are efficiently converted into energy, the body does not overload the intestine with extra tasks, which generates a feeling of lightness after meals. In protein metabolism, biotin helps convert amino acids into usable substances. This process reduces excessive protein fermentation in the intestine, which could cause discomfort, unpleasant odor, and excessive gas formation. Biotin also influences blood glucose regulation. When glucose circulates at adequate levels, the intestine does not suffer from sudden variations that could affect the speed of digestion. The strengthening of the intestinal immune system is another point linked to biotin. The vitamin participates in the formation of substances that support defense cells, and this prevents harmful agents from harming the balance of the intestinal flora. The indirect anti-inflammatory effect of biotin in the intestine is remarkable. By improving metabolic efficiency, the risk of subtle inflammations that could compromise intestinal tissue and cause persistent discomfort is reduced. Biotin is also connected to the synthesis of keratin and collagen, which, although better known for skin and hair, are also present in the structures that line the digestive tract. This cellular renewal ensures a healthy and resistant intestine. In the aspect of water-soluble vitamin absorption, biotin favors joint use with other B-complex vitamins. This synergy strengthens the intestine's ability to extract energy from various foods. Vitamin B7 also participates in the neutralization of unwanted compounds that arise during digestion. This helps the intestine better handle byproducts of fermentation and food breakdown. The small intestine is one of the biggest beneficiaries of biotin, since most nutrient absorption takes place there. With the action of the vitamin, this process becomes more organized and complete. In individuals who maintain adequate levels of biotin, fewer episodes of constipation are observed. This happens because the energy available for intestinal movement is constant, preventing slowed transit. Biotin also helps balance the production of digestive enzymes that act from the stomach to the intestine. With this, the initial digestion of foods is already more efficient, reducing intestinal overload. The relationship between biotin and neurotransmitter synthesis also deserves attention. Certain neurotransmitters influence intestinal movements, and biotin indirectly participates in this process by facilitating the conversion of nutrients necessary for their formation. The intestinal detoxification process is also favored by the presence of biotin. The body can convert metabolic waste into less aggressive forms, which are eliminated more easily through the digestive tract. By favoring the balance of the intestinal microbiota, biotin contributes to an increase in the production of endogenous vitamins, such as some from the B complex itself, further strengthening intestinal function. In the field of food sensitivities, biotin helps modulate exaggerated responses that could occur when the intestine is weakened. This reduces symptoms of discomfort after meals that could cause intestinal irritation. The vitamin also plays a preventive role against diarrhea linked to poor digestion. By organizing nutrient metabolism, biotin ensures that fewer undigested residues reach the intestine. The general feeling of well-being after meals is directly linked to the action of biotin. When the intestine functions in a balanced way, the body experiences less sleepiness, less abdominal distension, and more energy. Biotin helps the intestine maintain a natural rhythm. This rhythm is associated with good absorption, proper elimination of waste, and the prevention of discomforts that could disrupt daily life. Biotin promotes the production of enzymes involved in lipid metabolism, and this function is especially important for the intestine, since fat digestion depends on complex biochemical processes. When properly metabolized, these fats do not cause digestive overload or abdominal discomfort. In the large intestine, biotin supports the action of the bacterial flora in breaking down insoluble fibers. This process is essential to maintain fermentation balance and avoid excessive gas buildup. The continuous supply of energy to intestinal cells provided by biotin strengthens the intestinal barrier. This reduces the chance of harmful substances crossing the intestinal wall and entering the bloodstream. Biotin is a coenzyme in several reactions that convert nutrients into useful molecules for the body. This activity ensures that the intestine does not accumulate excess metabolic residues, keeping digestion organized. The production of short-chain fatty acids by intestinal bacteria is enhanced by biotin. These compounds protect the intestinal lining and contribute to healthy digestion. Biotin also plays an important role in intestinal cell renewal. Cells that make up the mucosa must be constantly replaced, and biotin provides energy support for this process. Amino acid metabolism, which partly occurs in the intestine, has direct dependence on biotin. This balance prevents excessive protein fermentation, which could cause discomfort such as gas and bad odor. The intestine has selective absorption mechanisms, and biotin helps these mechanisms function properly, making the most of the nutrients in food. Biotin strengthens the intestine's ability to handle heavier meals. By optimizing nutrient breakdown, digestive overload is reduced, minimizing the feeling of abdominal heaviness. The balance of intestinal pH is also favored by biotin. An excessively acidic or alkaline environment harms the microbiota, but the presence of this vitamin contributes to maintaining the necessary neutrality. Biotin indirectly participates in the production of hormones that influence appetite and digestion. When these hormones are balanced, the intestine responds more efficiently to nutritional demands. In the transport of nutrients through the bloodstream after absorption, biotin plays a relevant role. It helps transform nutrients into usable forms, ensuring that the intestine does not suffer from excess poorly processed substances. Biotin also improves the relationship between the intestine and the liver. The liver depends on balanced intestinal absorption to metabolize nutrients, and biotin harmonizes this connection. Biotin helps modulate the intestinal inflammatory response. When irritation occurs, the intestine may lose efficiency, but the vitamin acts to soften these effects. The intestine is directly influenced by emotional state, and biotin contributes to the synthesis of neurotransmitters related to well-being. This has a positive impact on intestinal function. Mineral absorption in the intestine is enhanced by biotin. Iron, magnesium, and zinc, for example, are better utilized when digestion occurs efficiently. Biotin also protects the intestine against the effects of nutrient-poor diets. By optimizing metabolism, it ensures that the body extracts as much as possible from consumed foods. The intestine needs a balance between beneficial and harmful bacteria, and biotin strengthens the predominance of beneficial bacteria. This reduces risks of diarrhea, discomfort, and digestive imbalances. The increase in intestinal vitality after biotin supplementation is reflected in overall body energy. With less digestive overload, the body has more energy for daily activities. Biotin participates in mechanisms that help the intestine recover quickly from periods of digestive stress. This prevents small imbalances from becoming persistent problems. The intestine is responsible for much of the body's immunity, and biotin strengthens this natural defense. This reduces the risk of unwanted agents causing digestive disturbances. Vitamin B7 also contributes to the intestine producing protective mucus in adequate amounts. This mucus is essential for food movement and for protection against irritating substances. Biotin helps balance the speed of gastric emptying, which directly influences the intestine. This balance prevents both slowness and excessive acceleration of intestinal transit. Biotin reinforces the connection between the intestine and the enteric nervous system. This system controls digestive movements and depends on balanced nutrients to function properly. Biotin also favors the utilization of soluble fibers, which are fermented by the microbiota and transformed into beneficial substances for intestinal health. Biotin helps regulate satiety, and this affects the intestine because more balanced and distributed meals prevent digestive overload. In this way, intestinal transit remains more stable. Vitamin B7 also helps in the synthesis of nucleic acids, which are linked to cell renewal in the intestine. With this support, the cells of the intestinal lining are constantly replaced with quality. The effect of biotin on energy metabolism reduces the chance of undigested residue buildup. This means that the intestine does not have to deal with exaggerated fermentations that could cause discomfort. In the process of glucose absorption, biotin plays a regulatory role. This regulation keeps the intestine free of abrupt fluctuations, preserving the fluidity of the digestive process. Biotin favors the integrity of intestinal villi. These microscopic structures increase the surface area for absorption, and when healthy, nutrient utilization is maximized. The large intestine benefits from biotin support in balancing the bacterial flora. This balance prevents episodes of diarrhea and constipation, maintaining the natural intestinal rhythm. Biotin also contributes to balancing lactose digestion when associated with other digestive enzymes. This reduces undesirable fermentations that could cause abdominal discomfort. In the metabolization of long-chain lipids, biotin acts as an essential cofactor. This process prevents partially digested fats from overloading the intestine and causing inflammation. Biotin influences the immediate availability of energy for intestinal cells. This energy allows absorption and transport functions to occur without interruptions. The regulatory effect of biotin on carboxylase enzymes is central to digestion. These enzymes depend on the vitamin to break down complex substances into forms assimilable by the intestine. Vitamin B7 also helps reduce symptoms of poor digestion associated with high-fat diets. This is because it improves the metabolization of these nutrients, making the intestine's work more efficient. Biotin also stimulates the activity of defense cells present in intestinal tissue. These cells form the first line of protection against elements that could destabilize digestion. The strengthening of intestinal cell junctions is another effect linked to biotin. These junctions prevent unwanted molecules from crossing the intestinal barrier and causing discomfort. Biotin also helps regulate the time food spends in the intestine. This balance prevents food from remaining too long, avoiding excessive fermentation. Vitamin B7 facilitates the use of branched-chain amino acids, which are important for energy and cellular recovery. The intestine, by better processing these nutrients, gains functional efficiency. The balance in carbohydrate metabolism achieved with biotin prevents the intestine from suffering glucose spikes. This factor is associated with regularity in digestion and absorption. Biotin promotes the absorption of essential fatty acids, such as omega-3 and omega-6, which have positive effects in reducing intestinal inflammation. The health of intestinal crypts, regions responsible for generating new cells, is strengthened by biotin. This support ensures constant renewal and vitality of intestinal tissue. The large intestine, when receiving fermentable fibers, transforms them into beneficial compounds with the help of biotin. These compounds contribute to microbiota balance. Biotin also helps in the utilization of fat-soluble vitamins. The digestion of fats organized by vitamin B7 allows the intestine to better absorb vitamins such as A, D, E, and K. The positive effect of biotin on intestinal motility leads to fewer episodes of cramps associated with slow digestion. Regular peristalsis reduces discomfort and improves the digestive routine. The intestine, when receiving adequate energy support from biotin, can better handle meals rich in fiber, which demand greater digestive effort. Biotin also helps prevent excessive fermentation of unabsorbed sugars. This balance prevents symptoms such as flatulence and abdominal distension. In the production of neurotransmitters that regulate mood, biotin plays an indirect role. Since the intestine is considered the second brain, this regulation also improves intestinal harmony. The small intestine, responsible for absorbing most proteins and carbohydrates, is directly benefited by the presence of biotin, which organizes the necessary enzymatic reactions.